Hi, so the first thing that we are going to look at in our chapter on polygons and circles is how to derive the perimeter and area for a regular N-Gon. So in order to do that, basically the idea is that we're going to divide up our polygon into a whole bunch of triangles. And since we know how to solve for sides of a triangle, we should be able then to find the perimeter and area of a polygon. So even though I have a pentagon drawn here, we're just going to assume that this inscribed shape here has n sides. Okay, so a couple of things. In this picture, when we think about the circle corresponding to this polygon, we'll notice there are two of them, right? There's the circle that's circumscribed about the polygon, and that's the one that touches it at each of the vertices of that polygon. And then you also have the inscribed circle that touches the midpoints of the sides of that polygon. So when I draw a line segment from the center of the circle, which is also the center of the polygon, to one of the vertices of the polygon, so a radius, for example, OA and OB. So those are radii of the circumscribed circle, and those are what we refer to as radii of the polygon. These segments, we could draw a couple more of them if we wanted to. Let's maybe switch this to red. So we could draw a few more of these. Oh, yeah, that's fine. So these guys, like OF, and this one that I just drew, where we draw from the center of the polygon perpendicularly to the midpoint of the side, that's what we call an apothem. Apothem, not a botham. And we need to draw both a radius and an apothem in order to figure out our perimeter and area. So what we're going to do is we're just going to isolate this little triangle for a minute, okay? And if I look at that triangle, OA is a radius, and we're going to call that H for height of our triangle, and then I'm going to call AF X, okay? All right, so first thing I want us to notice is that if I split this regular N-Gon up into a whole bunch of these little right triangles, well, I'm going to draw N radii, right? So an N-Gon has N sides and N vertices, so it's going to have N lines from the center to each of those vertices. And it's going to have N apothems, so N lines drawn from the center of the polygon to the midpoint of each of the N sides. So if I'm drawing all of those lines, what I'm doing is I'm splitting this regular N-Gon actually up into 2N of these little right triangles. So we're going to say a regular N-Gon is made up of 2N right triangles like triangle AOF, for example. Okay, so if we can find the length AF, or side X, that'll help us to find the perimeter, and if we can find X and H, then we know the area. So typically, the only information that we're given about a polygon is the radius of the polygon and the number of sides it has. Occasionally you're given the side length rather than the radius, or occasionally you're given the apothem length rather than the radius. But in this case, we're just going to assume that we know the radius rather than the side length or the apothem. Okay, so if I have 2n of these little right triangles, and I know that there are 360 degrees around a circle, then the measure of this angle theta is going to be 360 divided by 2n, right? I'm dividing it up into 2n pieces. In this case, 360 divided by 10. So you can count that up. It's a regular 5-gon. Or simplified, 180 over n, right? So where n is the number of sides, okay, of our polygon. Okay. All right, so then if I have this angle theta and I know r, then I can rewrite x and h using our sine and cosine functions. So for example, I can write that the cosine of theta is h over r, or h is equal to r cosine theta, and I can write that sine theta is equal to x over r, or x is equal to r sine theta. Okay, so perimeter is the easy one. So my perimeter, sorry if you can hear my kids yelling in the background. So my perimeter, well, if I know this length, x, is r sine theta, then how many of those x line segments do I need to make up my entire perimeter? Well, for this regular 5-gon, I'm going to need 10 of them, 2 for each of 5 sides. So in general, for an N-gon, I'm going to need how many? Well, 2 for each side, n sides, I'm going to need 2n of them. So I'm going to multiply x by 2n, so that's going to give me 2nr sine of theta, but theta is 180 over n. So 2nr sine of 180 over n gives us the perimeter of our regular N-gon. To get our area, what we're going to do, again, I'm going to have 2n of these. And how do we get area of a triangle? Well, we're going to take half the base times the height, right? So I've got 2n. Well, actually, I can go ahead and cancel the 2 and the half. So I've got n times x, which is r sine theta, or 180 over n, cosine, actually, I'll just leave it as theta for now. That's fine. So r sine theta, r cosine theta. And so if I combine my r's, I'm looking at nr squared sine 180 over n cosine of 180 over n. And that's how we get our perimeter. Now, fortunately, even if you have trouble memorizing these formulas, which they are useful if you have them, but if you forget them, you can always default to just building up the area or the perimeter from working with that single right triangle.